Alright, so your quiz on Unit 6, since I was out on Tuesday and Wednesday, I decided to go ahead and do a video. So your quiz on Unit 6 is going to focus on basically three things. Discrete and continuous random variables. Both of them will be on there. Discrete is going to be what you're going to use basically expected value and variance for. So those are three things kind of go together. Continuous random variables, you are going to be able to have to do ones like the one that was on the worksheet from Tuesday that you did in class with the sub, which I'll go over that in this video as well. Expected value, which is the same as mean. Again, mu, x bar, all of those kind of are the same thing. Variance is little sigma squared. And standard deviation, which is just sigma. If you take the square root of this, you get standard deviation. Okay, so those are the three main things that your quiz is going to be on tomorrow. So the first thing that I wanted to do is to do an example of number 16, which was one of your homework assignment problems that you had to do for homework. Okay? So in number 16, you're looking at an example with red lights, and this is a probability model. It tells you that it is. You should definitely confirm that it's a probability model. The way that you're going to confirm in a discrete probability model is to make sure that all of these probabilities here add up to 1. Okay? All of these do add up to 1. You can put them in your calculator to verify that. So for the first one, A, you're looking at how many red lights she should expect to hit each day. So expect, that should mean, okay, that's the mean. I'm looking at mu. Remember, going back to those formulas that you had, E of x is your expected value, which is the mean. You find that by taking the sum of the x times the probability, plus the x times the probability, plus the x times the probability. So what that looks like is the x times the probability, plus the x times the probability, plus the x times the probability, and so forth. So mu sub x is 0 times the probability, plus 1 times the probability, plus 2 times the probability, etc. Okay, up until you get to 5 plus the probability, so you get an average of about 2.25 red lights. Now you can go ahead and put that in as a string of numbers into your calculator. Okay, and what that's going to look like, I've already put quite a few things in here, so let's go back to my former. Oh, let's see if it has enough memory. Nope, it doesn't. Okay, so you can actually go ahead and put in this whole string. So 0 times 0.05 plus etc. 1 times 0.25, etc. Okay, when you enter, you get 2.25 red lights. Now, the next question, what's the standard deviation? Well, we talked about that standard deviation is the square root of variance, so you really have to find the square root of variance first. So you go back and you look at your variance equation. It says the variance of x is equal to the sum of the x minus the, there's mu we already found, squared times probability. X minus the mean squared times probability. X minus the mean squared times probability. So what that looks like is the x value of 0 minus the mean, we already found the mean, squared times the probability of that x. So in this case 0.05. Plus 1 minus 2.25 the mean squared times its probability. Plus 2.25 squared times probability, etc. Okay, so basically you are going to get down to this whole entire expression. Now, again, you can put that in your calculator, okay, exactly how it looks. Okay, now 0 minus 2.25 squared times the probability, plus 1 minus 2.25 squared times probability, plus 2, I forgot a minus sign there, so let's go ahead and go down there and insert a minus sign in. Second insert. Oops, I have a minus sign. Minus 2.25 squared times probability, plus 3 minus 2.25 squared times probability, plus 4 minus 2.25 squared times probability, plus 5 minus 2.25 squared times probability. Okay? Hit enter, you get about 1.5875. Alright, now, we said that the square root of the variance is equal to the standard deviation. So now you're just going to go back here, second square root of your answer that you just got, and you get about 1.26. So your standard deviation, or little sigma, is about 1.26. Okay, so that's how you find standard deviation and variance. Now, going back to our example of, do I have it in here? Okay, hold on for a sec. Alright, so I want to look at this example of the continuous, and again, this was on your continuous random variable worksheet that you got back today, and you did with the sub on Tuesday. So in this problem, you had, first begins at 0.2. So 0.2, well, it'd probably be helpful, because if you notice I have 0.4 here, to go ahead and count by tenths. Okay, so that's 0.1, 0.2, 0.3, and 0.4. Okay, so it starts at 0.2 and goes to 0.2, 1, 2, comma, 0.4. Then goes from 2.4 to the 0.3.4, so over to 3.4. And again, this axis 1, 2, 3, 4. Okay, and then horizontally to 0.34. So it goes up here and then across here. Okay, and that's your density curve. Okay. So the first thing that you have to do is you have to identify whether it's continuous or discrete. Well, I have a lot of values in here, and anytime you have a density curve, you're going to almost know that that is most definitely going to be continuous. Okay? So this is a continuous curve. So the first thing that I want to find is the probability. Well, we have to confirm it. And how do we confirm it? We have to confirm that all this area is equal to 1. Well, how much are each of these boxes valued at? Well, this first box is 1 times 0.1, so that must be that each box represents a tenth of the area. So there's 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths. So I have 9 full boxes that represent a tenth, and then I have a half of a box and a half of a box, so there's my other tenth. So all of my area is equal to 1 under the curve. So that's how I know that I have a legitimate density curve. Okay? Now, how do I know the probability it falls between 2 and 3? Well, here's 2 and 3. How much of that curve lies between 2 and 3? Well, I have 1, 2, 3, 4 boxes that each represent a tenth, so that would be 0.4. What about less than 2? Well, I knew between 2 and 3 was 0.4, so 1 minus 0.4 has to be 0.6. Now, you can confirm that by counting 1, 2, 3, so 1, 2, 3, 4, 5, and then 2 halves make another one, a sixth, so that's 6 tenths. All the time, in a density curve that is continuous, anytime you have a probability of x equaling something, it's 0. It should never be equal. There's no probability that that's going to happen. And then between 1 and 3, I'm going to have, between 1 and 3, I have 1, 2, 3, 4, 5, 6, 7 full, and then half of another one. Well, half of a tenth is 0.05. So I have 7.75 chance of landing between 1 and 3. So that's going to be all of this area right in here. Alright? So that would be an example of a continuous density curve. Now, let's go on to some of these random variable type of problems. So, given an independent random value with means and standard deviation shown, find the mean and standard deviation of each of these variables. Now, the mean is easy because pretty much whatever it says to do, you just take the mean and multiply it by that. Okay? So, for 3 times x, I'm to find the mean, and this is for a. So, mu sub 3x, I can just take 3 and multiply it by mu sub x. So, the mean of x is going to be 10, so 3 times 10 is equal to 30. Okay? Standard deviation is not as easy as that. Okay? Now, in order to find standard deviation, I really have to look at variance. So I'm looking at the variance of 3x. Well, here's all your rules down here, which again I'm going to give you. This is basically like a linear equation. It's just going to be 3x plus 0. I'm not going to have anything. Remember, the coefficient of x is going to be your b value. So this rule tells me I'm going to take b squared, which in this case is 3 squared, and I'm going to multiply it by my variance. Well, do I have the variance in this problem? No, I have the standard deviation. So my standard deviation is 2, so I'm going to take 2 and I'm going to square it, because if I take the standard deviation and square it, that's going to be equal to my variance. Okay? So then you're just going to do 9 times 4, which is 36. Alright, letter B. Letter B is another type of linear. So mu sub y plus 6. And again, that's a linear type of thing. And in this case, your b value is just 1. Tells me I'm going to take my rule over here is I'm going to take mu sub, here it is right here, I'm going to take a, and I'm going to add to it b times mu sub x. So I'm going to take a, in this case is 6, and add to it b, which b is just 1, times mu sub y. Well, in this problem, mu sub y, the mean of y is 20, so 6 plus 20 is 26. Okay? Then for my standard deviation, again I have to use the variance of y plus 6. Well, we said we only really have to worry about our b value, okay, because again using the same formula. So the 6 I really don't even have to worry about here. I'm just going to take my b value, which in this case again is 1, square it, and multiply it by my variance. And in my variance I have to take my standard deviation and square it. And this is again for y, so my standard deviation is 5. So that's just going to be 1 squared times 5 squared. So my answer is 25. Okay. Now for your rules of x plus y, let me go ahead and clear these. If you want to go back and look at these, just rewind the video. For C, I have, first of all, mu of x plus y. That I know is just mu of x plus mu of y. Okay, and again, that's just my formulas here. So 10 plus 20, which is 30. Again, variance standard deviation is not the same. Okay, for this one I'm going to use my rule here. My variance is going to be my variance times x plus my variance times y. Well, again, I don't have variance, I have standard deviation. So to get those, I actually have to use my standard deviation and square them. And then calculate it. 2 squared is 4, plus 5 squared is 25, so my answer is 29. Okay? Now for subtraction, it's pretty much the same thing, except for notice subtraction, it's still plus. Okay, so I do the exact same thing. So the answer to this one, for letter D, my mean will be different. Oops. X minus y. So my mean will be 10 minus 20, which is negative 10. My standard deviation, or my mu, though, x minus y, is still equal to the variance of x plus now the variance of y. And so to find the variance, I'm going to take my standard deviations and square them, and notice it's going to work out to be the exact same thing. Okay? So I hope this helps. Don't worry about e right now. That's just taking two x's and putting them together. But I hope this helps a little bit, and happy studying.